In this video, we are going to make a decoder. Decoder is a circuit to translate an input code and activate the corresponding line on output. Decoder has n input and 2 power n output lines. All output lines are 0 except the line coded in the input. For instance, if the code on the input is 6, the corresponding line in the output, line number 6, will be activated and will be set to 1. All other lines are set to 0. Design of 3 to 8 decoder is shown here. In this video, we are going to make a 3 to 8 decoder with enable control. This is used in register file for enabling write signal of one specific register. We have total of 8 registers in our mini processor, so that's why we use 3 to 8 decoder. Wiring here might look complex, but the key is to create all possible combination of S2, S1, and S0. Starting from S2 not, S1 not, S0 not, which is line number 0, all the way up to S2, S1, S0, which is the line number 7. Then a level of AND is added to the end output. This AND level is controlled by the enable signal. So when enable is 0, the decoder output all are 0. And when enable is 1, the decoder output is as a normal decoder. So let's just start creating the circuit. Wiring for creating all combinations of S2, S1, S0 are done. We need to add one level of AND gates to involve the enable signal too. Okay, all wirings are completed. Let's connect binary switches, 4 binary switches to the input and test the circuit. Enabling the show value. Restart the simulation. Okay, let's verify that enable signal is working. As long as enable signal is set to 0, no output should be set to 1, no matter what is the value of S2, S1, and S0. Let's have a label for these signals here so we know which one is S2, which one is S1, and which one is S0. Okay, so that is confirmed. As we can see, no value of S2, S1, and S0 can flip the output as long as enable is 0. Let's set enable to 1 and then verify the functionality of decoder. The line at the top here is line number 0, followed by line number 1, 2, 3, 4, 5, 6, and 7. The code that we are putting in here, S2 is the most significant and S0 is the least significant, should trigger the corresponding line. So if we have 0, 0, 0, which corresponds to line 0, this should be the only line that activates. Let's try 0, 0, 1. That goes to the next line. Let's try 0, 1, 0, which is line number 2. Let's try the next line, 0, 1, 1, line number 3. Then let's try 1, 0, 0, line number 4, line number 5, line number 6, and finally line number 7. That confirms the circuit is working as expected. Let's save this file as decoder 328, and then we move on to create a symbol from this circuit. Let's save this file as a symbol. Remove all the signal drivers and replace them with ports. We need 3 input ports and 8 output ports. Naming of the signals are very important here, because the significance of the digits is important for passing in the right code and getting the right decoded number on the output. So make sure you carefully label the ports. Make sure you're saving this file, and then let's create a device symbol. The generated symbol looks sane. Let's save this in the library. I'm going to open the CPU project library. Okay, our symbol is ready. The next step is to test this symbol. Let's attach binary switches as input. We are going to test the circuit the same way that we tested the initial circuit. Starting a simulation, enabling the show value. Initially setting the enable to 0, making sure no input can flip the output to a non-zero digit. That is confirmed. Let's set enable to 1 and then try every possible combination. 0, 0, 0 for line 0, 0, 0, 1 for line 1, 0, 1, 0 for line 2, 0, 1, 1 for line 3, 1, 0, 0 for line 4, 1, 0, 1 for line 5, 1, 1, 0 for line 6, and ultimately 1, 1, 1 for line 7. That confirms our test bench is completed and the symbol is working as expected. We can save this file as the test bench. And that's the end of the video.